Software maintenance is the process of modifying a software product after it has been delivered to the customer. The main purpose of software maintenance is to modify and update software applications after delivered to the correct faults and to improve performance. So after delivering our product, that is not the end point of this whole process, right? So by time passing, sometimes they want to do some modification with the technologies in to their system, and also when they using that system and being time pass, we need to do some modification. Therefore, it's compulsory to have a maintenance. So I have listed few points why we need maintenance. So we need maintenance to correct some faults while they are doing or while they are working with the system. If they do some thing not applicable to the system by mistake only, so sometimes some things will happen to the system. So in that case, they need to have a maintenance to correct that. In software maintenance, so basically we can divide our key issues in software maintenance into two parts: technical issues and the management issues. So we can find many technical issues like limited understanding, testing, impact analyzing, maintainability. Those factors will belong to the technical issues. Then, and the other thing is management issues, alignment with organizational objects, staffing, process, organizational aspect of maintenance, and outsourcing. Those are some management issues. Then, maintenance process. So, maintenance processes provide needed activities and details input and output to those activities. And I have listed few maintenance activities. You can see that unit activities, support activities, maintenance planning activities, software configuration management, and software quality. Those are the main maintenance activities that we can see in maintenance process. So this is the IEEE 1219-19 maintenance process activity. This is a standard. This diagram will start with the classification and identification. So you know it's very our initial stage, and it involves activities to identification of requirement of modification or maintenance. So next stage is analysis. So this in this stage, the modification is analyzed for its impact and on the system, including safety and security implications. So third step is design. So in this stage, new modules which need to be replaced or modified are designed against requirement specifications set in the previous stage. And next stage is implementation. So during this stage, the new modules are coded with the help of structured design created in the design steps. So every programmer is expected to do unit testing in parallel. In this stage, we are doing all these things. So next thing is system testing. So we are starting our testing part here. So integrating testing is done among newly created modules, and integrated testing is also carried out between new modules and the system. And next thing is acceptance testing. So after testing the system uh, internally, uh, it is tested for acceptance with the help of users. So at this stage, we are doing our testing part with the help of our users. And the next stage is the final stage, which is delivery. So after the acceptance testing, the system is deployed all over the organization either by small update packages or refresh installation of the system. So final testing takes place at the client and after the software is delivered. So we are doing all the final stage of testing at this time, and then we will deliver our file. So then techniques for maintenance. So we can apply techniques to so first thing is program comprehension. So programmers spend considerable time in regarding and understanding programs in order to implement changes. Or code browsers are key tools for programming comprehensions. Clear and concise documentation can aid in program comprehension. So next technique is re-engineering. So re-engineering is defined as the examination and alteration of software to reconstitute it in a new form. So when we need to update the software to keep it to the current market without impacting its functionalities, it's called software engineering. That's what we call software engineering. So it is a through process where the design of the software is changed and programs are rewritten. In this stage, in this technique, we can rewrite our programs as well. So next technique is reverse engineering. So it's reproduction of another manufacturer's product after detailed examination of its construction or composition. So it's a process to achieve system specification by truly analyzing or understanding the existing system. And also this process can be seen as the reverse of our SDLC model. Process about the aspect related to the managing a software project, managing the people who are contribute to the development of the software, and about adhering to the process to achieving the target. So activities in the software project comprise a combination of the engineering and management activities, and also need to understand management and engineering aspect of software project management and the importance of managing. So when we talk about the project management, we have to think about software quality and the product cost and schedule. Those are major important points of project management. Right. Software project management is aims to ensure that the software is delivered on time. It should be delivered on time within a given budget and with required functionality and satisfy the requirement of the client. So if you are a project manager, you have to consider these all these points. So you should deliver your product on time, and you should consider about the budget. You have to do your project within the given budget, and you have to develop your system with the required functionality. And finally, customer should satisfy about your customer should be satisfied about the system, right? So these are the management activities: writing a proposal and planning the project, scheduling the project, estimating the cost of the project, monitoring and reviewing the project progress, and selecting, hiring, evaluating personnel, and writing reports and giving presentation. Those are the management activities included in project management. Once you got the client and ask, let's say, when they ask about a system, what you're going to do is you are going to use some techniques and you are going to get some requirements from the client. According to the client requirement, you need to write a software requirement specification document, right? So you have to prepare a proposal. So then you have to propose it into your client and get the approval. So in that document, you need to have a plan of your project and how you are going to schedule the project and how much will be the cost for this project, and also you need to monitor and review the project progress, and you need to select, hire, and evaluate in other personnel. So let's say if you are not having developers or if you are not having enough personnel, so you have to hire. So in that case, you have to look forward it. And also, finally, you have to write a report and you have to give some presentation. So those are the major management activities in project management. And there are 4 P's in project management: people, product, process, and project. People, the most important element of a successful product or successful project. And next second P is the software to be built, and process, the set of frameworks, activities, and software engineering tasks to get the job done. Next, final P is project, all work required to make the product real. So those are the 4 P's in project management: people, product, process, and project. So when it comes to the people, who are the people in this? So people can be stakeholders or team leader or software team. So those are the people in project management. So stakeholders, who can be the stakeholders? Stakeholders can be senior managers, project managers, developers, customers, end users. All these personals are belongs to the stakeholders. So team leaders. When we talk about the team leader, we can talk about the MOL model. MOL means motivation, organization, and I4 ideas, or we can call it innovation. So motivation, the ability to encourage technical people to produce to their best ability. Organization means the ability to mold existing process that will enable the initial concept to be translated into final product. And ideas or innovation is the ability to encourage people to create the feel correct creative even when they must work with boundary bounds established for a particular software or product or application. If you are a team leader, you have to consider this motivation, organization, and these factors you need to be considered when selecting a software project team. A difficulty of the difficulty of this problem to be solved, the size of the resultant program in code, inline of code or function points, the time that the team will stay together, and the degree to which the problem can be modularized, the required quality and the reliability of the system to be built, and the rigidity of the delivery date and degree of the sociability, or we can call it communication, required for the project. These factors you need to consider when you're selecting software projects. So if it is an agile team members must have trust in one another, and the distribution of the skills must be appropriate to the problem. And team is self-organized. Self-organizing should be consist of adaptive team structure, uses elements of constantine, random, open, and synchronous paradigms, and significant autonomy. If it is a self-organizing, it should be considered of these 3 points. And next, P is a product, right? So you need to know about the product scope and problem decompose. What is the product scope? How can we determine it? Define scope by context, information, objectives, and function and performance. By considering these 3 points, you can identify the scope of your product. Problem decomposition. So sometimes we can call it partitioning or problem elaboration. Is at the core of the software requirement analysis. So once scope is defined, the problem is decomposed into constituent functions, or the process that will be used to deliver it will be decomposition process continue until all the function or problem classes have been. Next point is configuration management. When you're going to configure management, you have to follow these steps and you have to consider these points. Then I'll move to the third P, it's the process. So genetic phase that the the generic phase that characterize the software process, defining, development, and support are applicable to all the software. So selecting process model that is appropriate for the software to be engineered is important. So you have to select the relevant or most suitable process. I will come to cost estimation later. And final P is project. So factors that influence the end result. So size, delivery deadline, budget and cost, application domain, technology to be implemented, system constraint, user requirement, availability resources. Those are will related to the project. So those are some project management skills. If you are a project manager, you should have these skills inside you. So you should have communication skills, organizational skills, team building skills, and leadership skills, and copying skills, and technological skills. If you are a project manager, you should have all these. What is cost estimation? So there is no simple relationship between price charged for a software system and it is development cost. Factors affecting productivity. So there are many factors will affect for the productivity, and these factors will cost, right? So include individual aptitude, domain experience, development project size, tool support, working environment. Those are factors affecting your system. And software is usually priced to gain contract, and functionality is adjusted to price. You can calculate cost through labor. Labor means the cost of team members working on project, both terms of wages and time. And we can cost materials and equipment, the cost of resource required for the project, from the physical tools to software to legal permits. Or we can cost facilities, the cost of using any workspace not owned by the organization like this, and vendors, the cost of hiring third-party vendors or contractors, that may be a cost. And uh, we can count cost as a risk. The cost of any contingency plans implemented to reduce the risk. So those factors will be counted as a cost. So you can consider all these points when you are going to make your budget. And there are different techniques of cost estimation, and two or more can be used when estimating cost. Yes, there are more estimating techniques, and you can use one or more when you're going to estimate your cost. So I will simply tell you what are those techniques. Technique is analogous estimating technique, and then we have parametric estimating technique, and also we have bottom up estimating and 3-point estimating.